Let's solve the problem. Here you can see how to solve an SQL problem from beginning to end. So we have binary tree nodes. Solve challenge. You are given a table BST containing two columns n and p, where n represents the value of a node in binary tree and p is the parent of n. Write a query to find the node type of binary tree ordered by the value of the node. Output one of the following for each node: root, if node is root node; leaf, if node is leaf node; inner, if node is neither root nor leaf node. Sample input. So what is n and p? The binary tree below illustrates the sample: 5, 2, 3, 1, 5, 8, 6, 9. Okay, what is n and p? So 1 is a leaf. Why is 1 a leaf? Because 1 is a leaf and the parent is 2. And p is the parent of n. So 2 is the parent of n. And n represents the value of a node in binary tree. So here is the value 1, which we have here, n is 1. And the parent we have here 2. 2 is the parent. And from 2, the parent must be 5, yes. So 5 is the root. So we have 1 is the leaf. How is a leaf characterized? Leaf is no, if node is a leaf node. Okay. There are 3 types of nodes. What characterizes a root? A root is easy because a root is where the p-value is null. A leaf, so let's write that down. Root definition, p-value is null. Leaf, if node is leaf node. Okay, what makes a leaf node a leaf node? What makes you a leaf node? So you definitely have a parent, but inner has a parent too. But inner, the parent of inner, is always the root. The parent of inner is the root, because 2 and 8 are inners, and the parents from 2 and 8 are both 5. So the definition of an inner definition is key value is the root. So anything else would be the leaf. The leaf would be definition a leaf definition is anything else. So p-value is not null and p-value is not the root. Okay, so let's write the query. How would we write the query? First step, we would make a pre-query to find the root. Find the root. Second step, define root, inner, and leaf. And that would be the plan for now. We might have to do more steps, but we are going to figure that out on the way. So we want to have the output of the n ordered, the smallest value, and then it's getting bigger. So it's ascending. But first let's get the root. Let us get the root. How do we get the root? Well, the root should be relatively easy. The table I think is BST. So we select from BST where the column P is null. P is null. We should just get one number out here. If I remember correctly. 15 null. Why do we get null out? Because we get a star, but we just want the n. Because we want to have the n, yes. We want the n column, so we don't want 15 null, we just want the 15. So we have the root that is 15. So that is our first condition that we already fulfilled, our first definition. P-value is null, and that is 15. 15. So we want the inner. Definition is p-value is the root. As you can see, before I wrote any SQL, I was thinking about the problem. I was writing my notes. And then if I have it clear in my head what I want to do, then I can start the query. Select N, so we have now the root. We want the inner value. So inner we defined as p-value is the root. Select N from PST where p equals, and now we can make a subquery SQL. You just open the brackets and you write exactly what is written here. So that way you can, so you make p equal, and because we just got a number out here, 15, we can just put this query as a p equals, and then we also get a 15 out. We don't need this one anymore now. So we have 4 and 11 as the inner value. That's great. So let's write this one. Let's save this one as a temporary code save. So how do we get all of them together? Maybe we could make a union, I think. That would be a solution. So what I'm thinking about is to write n. What I'm thinking about is to make a one query, then a union, then a second query, then a union, then a third query. And then you have it all one under another. And you have to write inner, leaf, and root. So this one was the definition of inner. We can write inner. Let's just test this. Okay, this is working. Let's make the first. Select. I'm writing the root from BST where p is null. Now I want to union this one. See what comes out of here. This is not working because we just have one column here. We have to have both the same number of columns. So we have n, and this one was the root definition. So we write root. Inner root. Okay, that looks not too bad. And now let's write the third definition. So we have the third definition. Third definition is here. P-value is not null, and p-value is not the root. Okay. Select n What's the third one? How is it called? I think it's called leaf, right? Yes, leaf. Let's write leaf from est where, so we have the conditions. P is not null, that's the first condition, and P not equals, but P is unequal to the root. So we don't need equal sign, we need the unequal. The root definition, we have it here. So we make a subquery again. We take this one, put it here. So now we have the two conditions for the leaf. I think that should work now. Let's see if it does. So now we have a lot of leaves here. And from my opinion, that should be the solution. Except one thing is missing. It's not ordered. So we should order by n value. We have it here. So let's do this here. Order by bny by n, and we want ascending. I think that's the default, but I wrote it anyway. So now we only have the leaf ordered. Okay, he does not order the ones before the leaf. Do I have to, did I put a union here? No, I didn't. Should I not also put a union in this one? I think I should. Maybe then he's ordering everything. Let's see. He is ordering everything and it looks okay. But still I get the wrong answer. And I wonder why. Leaf inner, leaf root, leaf inner leaf. Okay. So we don't have it right, I think, because we put the big letters. Should only start with a big letter. So something is wrong here. Obviously my definition of them, I think, was not right. So we define the leaf as the p-value is not null and p-value is not the root. But this seems like an insufficient definition. Why? Because we were looking at this example and there the case is true, but here we have only 3, 6, 7 nodes, and in this case it is true, but this definition is not sufficient for our case now, as we have here 15 roots So we have to kind of make a picture of what we are actually looking at here. So let's try to make a picture of this. So let's try to make a picture so that we have a better understanding of this. We have 15 nodes. Here we're gonna have the number 1 node. This is gonna go into number 2. And here we have another one, number 3. There we have 3 nodes. Now we come another one that is 4. Here we have 5. Then we have 6. And then we have 7. And now we do the next row. We're still not at 15, so we continue. We have 8. Very beautiful. 9. 10. 11. 12. 13. 14. And 15. And now we have a clear picture of what this actually looks like. We have the 15 nodes. And what would be an inner node here? What would characterize the root is clear. It is up here, and the leaves, I think all the ones above are leaves, and the inner is probably everything between the bottom row and the top root, if I understand now correctly. So we have to change our definition. Our definitions were not sufficient. The root definition is still true. The p-value is null. That is the root. The inner definition is not true. The p-value is the root, because we have here inner nodes 4, 5, 6, 7, that the parent is not the root, and there are still inner values. So the question is, how do we have a sufficient definition that we can characterize the inner nodes correctly? And how can we characterize the other nodes correctly? Because this is also not true. P-value is not null, and p-value is not the root. They meet these definitions. The p-value is not null here. The p-value is 2 and 3, and the p-value is not the root. That is also true here, but they are not leaves. They are inner. So we got a bit of a problem here. The question is, how can we solve that? What makes these inner nodes inner nodes? Well, we know that the inner nodes, they have 2 strings here that the leaves don't have. So the leaves are not a parent of anyone. So the leaf definition is the p at the leaf, the p value, for example 15, is not apparent to anyone. P value is not a parent value. The leaf is not apparent to anyone. That is, I think, a sufficient definition of the leaf. And the inner definition would be well, we define the leaves and we define the root now. We can just say about the inner then, that is the p value is not a null and p value is parent to at least one. So the inner is parent always to two leaf values, but at least one is also enough definition to define an inner value. Okay, but how do we translate that in a query, in an SQL query? The root is very simple again. The root value is very simple. So maybe we can define the leaf before. That looks like an easier definition because it just has one condition is not a parent value. So maybe we should get the list of parents values. All the values that are parent to somebody. How could we get that? So we save our code here. Root. This one, I don't know what to write here. So we want to get select P from BST. We want the N, the values we want to have. The nodes. Nodes from BST. Or first let's get the parents. Let's get all the parents here. Select P from BST. Very simple. So let's select distinct P. Distinct P from BST. So now we got all the parents here. We don't need null here in this list. Where P is not null. Don't want the null value because the root we can get anyway. is not really a problem. And now we would like to get the nodes that don't have these values, because then we have the leaves. P-value, node value. Actually, you have to write node value, and node value is not parent value. So then we can make an accept list. I think that would be good. Select n from PST and do it accept. And then we select this one. So now, I think now we can exclude everyone that is not a parent. Now we have 1, 3, 5, 7, 8, 10, 12, 14. 1, 2, 3, 4, 5, 6, 7, 8. 8 values. 2, 4, 6, 8. Yeah, we also have here 8 values on the bottom. So that looks about right. Now we got all the leaf values. That's good. We also know the root value. Now we just have to get the inner values. How do we get the inner values? Very easily here. Well, the inner values are everything except the root value and the leaf value. So first let's say this one is inner. How can we write inner now? Inner. Yep, that looks right. Actually, we should not write everything in big brackets. We write it like this, yes. Now we get the root value. And root all here from PST where T is not null. We don't need the semicolon here. And I would like to union this ones. See how this one is looking. Rot, I wrote rot. Oh, that's also interesting. Where P is not null, oh, I mean where P is null, sorry. Where P is null, not rot, but we need the root. So now we have the inner and the root. We only need